Yeah, my name's York. I'm part of the Hyperlane engineering team. Hyperlane's an interoperability protocol. Today, I'm going to try and cater the talk towards app chains, because this is the app chain venue. And so, yeah, it's basically a new protocol that I think provides an alternative to some of the existing protocols that maybe is more customizable and generalizes better to some of the innovation that people are doing either at the VM level or at the consensus level, or if they're using a new DA layer, or basically like some of the existing solutions in the existing app chain frameworks fall short in certain places. So we've tried to design the protocol with modularity in mind, and kind of future-proofing the ability for app chains to accommodate new architectures, whether they want to migrate to a new consensus algorithm or a new VM, those sorts of kind of upgrades. Our protocol is kind of designed to facilitate that. So I'm going to be talking a little bit about how we've done that and what developer tools and Legos, we call them, that developers can build with to basically adopt these new chain features on their app chain and continue to use kind of the same API without having this like relatively heavy migration. So just to provide some context on where we are today, why we're having an app chain day, I think it's important to just reflect on the evolution of the technology we're working with. And so I think you can think of Bitcoin as like the OG app chain. It was just a simple payments chain, and some smart people came along, like Vitalik, and realized that you could generalize some of the blockchain technology to arbitrary computation. So it didn't just have to be app chains. And we could use smart contracts. And so that's where Ethereum and Near and Solana and now Move are kind of building their chains around this idea that you can verify arbitrary computation. And maybe a year or two after that, we had kind of another pendulum swing back towards app chains and people realizing that actually for certain use cases, or if you really wanted to push your application to the performance or security limits, you might actually want to have an independent chain. And these sorts of frameworks like the Cosmos SDK and Polkadot started to emerge to allow applications to basically launch their own chain without building out the new consensus algorithms. This is where a lot of teams here are in the Cosmos ecosystem. They are all using like Tendermint, and there's been a bunch of teams talking about the CosmWasm module. That's just a module that plugs into the Cosmos SDK that enables you to have smart contracts. It's kind of interesting to see the Cosmos ecosystem now like swinging back towards the CosmWasm like smart contracts like tooling, with the original motivation of the Cosmos SDK being this app chain framework. So we're seeing that basically over time, different applications have a recognition that actually this like diversity and like heterogeneous like set of chain architectures make sense for different use cases. For certain Cosmos chains, you want CosmWasm to expose certain features to developers. Elsewhere in the ecosystem, we're seeing people invest a lot into rollups as a scaling strategy, which is somewhat different from the kind of app chain and Cosmos vision of how to scale. And that comes with its own set of kind of new infrastructure problems. And then in the future, maybe we'll have even more complex solutions, which ultimately hope to solve some of these like scaling problems more holistically. But you don't want to look too far ahead because we already have enough complexity today. So yeah, this is mostly just providing some context that look, these new architectures and these new app chains are actually being adopted across the ecosystem. Even institutions like Coinbase have taken the leap, which I think was a huge validation for kind of like this idea that you'll have individual businesses or applications with their own chains. A lot of their products are starting to come on chain. I was just talking to someone yesterday from like Coinbase Commerce about basically what they want to allow as like a point of sale experience on Base, which I thought was pretty cool. But yeah, all that's to say, like, this isn't just a theoretical question anymore of like, do app chains make sense? Like, the ecosystem has actually moved in this direction. And on the flip side, the resultant complexity for developers to navigate kind of all these new architectures and these different choices of, okay, Coinbase is using the OP stack, but DYDX is using the Cosmos SDK, and someone else is using Orbit, or the next chain stack that comes out, is all the interfaces for like moving between these chains are super fragmented, and just even if you look at like the L2Beat website, which is mostly just roll-up bridges, like by market share you can see kind of, this is a pretty old screenshot, but by market share, like there's a decent amount of like diversity, and most of the top roll-ups in terms of TVL actually have completely different interfaces for bridging from the L1 to the L2. And so like as an application developer, if you want to take advantage of one of these new infrastructure layers, you have to basically custom integrate all these like interfaces, and if you want to move between L2s, or you want to go from one of these L2s to Cosmos or whatever, that's a whole completely different protocol and a completely different interface. And moving assets is different from moving data, and there's like all of these different things that you as a developer have to understand, which I think at Hyperlane we feel is kind of slowing the progress of these technologies actually scaling the ecosystem, and kind of solving the like existential problems that motivated a lot of these new app chain like frameworks to even exist in the first place. And so at Hyperlane, what we've tried to do is build a protocol which is agnostic to any of these specific app chain frameworks, and provide basically a consistent application interface to developers across all of these different kind of heterogeneous chain architectures, in such a way that they don't have to understand all of the underlying like framework interface choices or trade-offs around cost. And so basically, the most general purpose API for application developers to move between chains is what we call a general message passing interface. IBC and other interop protocols have this, but the idea is you just want to send data from a contract or an application on one chain, you want to send it to another chain, all you should need to specify is the destination chain identifier, what address you want to send it to on that chain, and you shouldn't have to care about, is it an OP stack rollup, is it a Orbit rollup, is it a Cosmos chain? Like these sorts of questions shouldn't be surfaced in the interface. And then as basically people who are working on these app chain frameworks continue to innovate and continue to improve the available options for app chain users, like let's say Celestia or Eigenlayer, who's presenting after me. As they continue to innovate at the kind of chain layer, you can provide a consistent interface to application developers to benefit from those innovations without them having to basically do a whole re-architecture of their application. So you don't need to maintain a new implementation of your application to understand basically all these new things as they come out. It just becomes a kind of configuration layer for your application rather than kind of like architectural implication that you have to keep changing as, clearly things are evolving at a very rapid pace. You don't want to subject yourself to, re-architecting your application every time a new one of these frameworks sees some traction. And so the specific thing I wanted to talk about today is what we call modular security in the Hyperlane protocol, which is this idea that you can actually configure the security on messages being passed between chains independently. And so if you guys are familiar with the IBC protocol, in practice, basically all messages that are passed over IBC kind of use the same verification mechanism. And that looks like a Tendermint-like client. So it's a consensus-like client, and any message that passes between two Cosmos SDK chains essentially uses the origin chain's Tendermint consensus to verify whether this message was actually passed or not. This is like a nice assumption for chains within the Cosmos SDK, but as soon as you want to connect one of those chains to, an OP stack rollup or a, Celestia rollup or whatever it is, you have a few problems. And so I just wanted to highlight some of those. So one of the problems is that when you have this Tendermint-like client that's implemented and kind of seen a bunch of adoption across the Cosmos ecosystem because everyone's using the Cosmos SDK, that's great. It's available off the shelf. But if you want to use that same Tendermint consensus as security for messages going from a Cosmos chain to an Ethereum chain, you now need to re-implement the Tendermint-like client in Solidity smart contracts. It's no secret, basically, that this is quite challenging. A lot of people have been attempting to do this for years, and there's strong reasons why this isn't available off the shelf today. Or similarly, there's not Tendermint-like clients implemented as a Solana program or as a Move program on these new VMs that are coming out. And so by making this assumption that within the Cosmos SDK, everyone's going to share the same kind of security assumptions around consensus, you're actually preventing that ecosystem from connecting to the frontier of where the chain stacks and the chain frameworks are evolving. And so with Hyperlane, we're trying to basically subvert that assumption. So instead of every path that messages are passed on inheriting the same kind of security model, you can actually independently configure those things. And so as a kind of demonstration of that, here's just like a topology of what the Hyperlane protocol looks like. And for different message recipients, they each can specify their own security preferences. And where those, they basically get to decide, am I going to block on an Ethereum-like client or a Tendermint-like client being available in the chain that I want to run my application on, or am I going to maybe actually take on a slightly stronger trust assumption in exchange for getting to market on one of these emerging ecosystems. And really this is what Hyperlane enables, is basically getting people to market, enabling this kind of long tail of innovation rather than imposing some universal trust assumption that prevents people from kind of pragmatically growing and expanding to new ecosystems. And so yeah, if you're a Cosmos chain today, and you want your application to be available to users on Solana or one of these new Move chains, you're going to have a hard time basically using IBC to pass messages to and from those chains, mainly because the only security model that's available to you is this Tendermint-like client, which is quite hard to implement and also quite hard to operate. There's kind of a lot of liveness assumptions. And so at Hyperlane, we've built out basically a bunch of different off-the-shelf security models that you can choose from, basically as like a menu or a set of Legos, kind of like a builder's kit that you can choose from for different paths, and you just configure them as a developer rather than having to go out and kind of like invest in this long R&D cycle. You can just say, okay, I'm instead of waiting for the Tendermint or Ethereum Lite client to be implemented on my chain, which might require like ZK or something to be actually practical. Instead, you can say, I'm actually just going to run some validators that have some incentives in my application. Like maybe they're staked in my DeFi protocol on Ethereum, and so they have some exposure to my application. And I'm just going to set a very simple multisig on Aptos or on one of these Move chains or on Osmosis or on Solana that doesn't have this difficult to operate and complex consensus-like client. It's literally just basically like a trusted set of participants that have some existing risk exposure to your application, and this allows you to get to market on these new chains and say basically, okay, now our application's on Aptos and it's on Solana, but you didn't have to wait 3 years for the Interchain Foundation to like pay someone a few $1 million to like get someone to build a Move Tendermint like client or something like. Yeah, so like the idea here is like we don't want to gatekeep or like kind of be maximalists about security assumptions that we're willing to make. And in fact, like if you look at the state of the ecosystem, people are not making the same security assumptions, right? Like different applications justify different trade-offs. And so like imposing some universal security model just stunts basically progress on the application side. So yeah, I wanted to quickly like hop into what the flow looks like just for the sake of like demonstrating that this is actually like pretty available off the shelf. So if you were going to deploy, let's say Hyperlane on some new chain where there's an existing smart contract implementation. So let's say there's a new Solana chain. We're working with Eclipse and we're on their testnet right now. It's a Solana fork, and Hyperlane has already implemented the scalable programs, which represent the kind of like on-chain footprint of the protocol. If you want to have the deployment onto Eclipse, basically just take on some validator set from a bunch of other chains where there's already some validators, let's say Ethereum and Injective, which is the Cosmos chain. You can just use our validators, which are already operating there. You can choose the thresholds. I think this is basically just like passing in the addresses, but we have a guide basically on our docs for the process of, oh man, the Wi-Fi here is not great. Here we go. We basically have a super like simple and kind of like procedural guide for spinning up these validators. We actually are working on our relayer, and in our validators there's basically these like simple Rust traits that just abstract the like chain interaction of like how do you do an RPC call, how do you submit a transaction, but all of the other business logic for Hyperlane of like indexing messages and requiring that they paid for gas and basically doing all of the kind of like user experience stuff on top. All of that is like mostly agnostic to the VMs, and so the actual like business logic of the protocol that we're working on in house, and we're trying to add these like additional developer primitives on top of, All of that extends to these new things, and all you have to do is come and implement this kind of like very well scoped set of on-chain surface area. And we've even gone so far as to like basically provide a guide for how to do this.
Almost like a schema.
Yeah, exactly. And so like, you know, we have the message encoding, and you just have to basically know how to encode and decode that in your smart contract. And we have the function interfaces that we like want you to implement. And we have examples linking to the different implementations. But yeah, this is like the spec. And yeah, it's not, you know, we just scrolled through all of it. It's not very long. So yeah, the hope is that it's not too difficult to add these new implementations. Yeah. Like we're even working with like you'd be surprised at like we're working with Cadena, we're working with there's like a ton of like really long tail VMs that have actually come to us and recognized, wow, like this is a way for us to get connected to all these existing ecosystems. We're working with Rootstock, which is like a Bitcoin smart contracts network. So I think we're starting to see like people, the idea clicking in people's head around this like modular security and interop setup. Cool. Well, yeah, thanks guys for coming. I'm happy to connect afterwards. Out of the box UI that you can just go in and fork and rebrand, and you know, add your application special sauce on top of, and the application like message encoding of what a token bridge like message means going over the wire is agnostic to what VM we're interacting with and what consensus that chain has. And so like, again, this is an architecture that allows like your application interface, which is just this like, you know, token bridge, send this over the wire. You don't have to think about any of the underlying you know, chain infrastructure. Yeah, I recommend people go check this out and hack around with it. We've put in a lot of dev time into making sure that the kind of like multi-chain wallet selection and everything works well. And the hope with this is that people come up with more interesting applications than just token bridging, and that this is just like a kind of foundation for you to go and add your own application on top, whether it's on DeFi protocol. But yeah, it's all hooked up to kind of the Hyperlane SDK. It renders nicely for users the progress of an interchain action. So like it'll show you your message progress in our Explorer. It'll allow you to like basically see your addresses across a bunch of different chains. And this is all open source. So basically if you want to go in and you want to add maybe you're even a researcher and you're building a new VM. Maybe you're building some like parallelizable VM that you want developers to start building applications on top of. Today, getting that type of research to market is extremely difficult because you have this cold start problem of basically convincing a chain to use your VM, or going out and raising a bunch of money to like bootstrap a set of like validators or developers who are willing to like run this new chain architecture. And a benefit to like having this type of unified framework that is agnostic to the VMs is you can basically demonstrate the user experience in like a testing environment before actually going out and doing all of that like capital raising or kind of like ecosystem growth investment, and justify to people, hey, like this VM or my research actually enables this great user experience, and here's a link, and you can move from like Ethereum testnet to this thing super easily. And I think that's like a way more compelling pitch than hey, like in 4 years, like this thing will change the ecosystem and like, you know, give me $1 billion. So yeah, there's a few. This is another example of like a developer primitive we built on top, also taking some inspiration from IBC. So like I said, we want a consistent application interface that's agnostic to the VM or to the underlying chain. This is an example. So what we found oftentimes is that people don't like, or people have difficulty writing their own smart contracts in all these different VMs, and maybe they're only familiar with one of these ecosystems. Like maybe they're an EVM developer, or maybe they're only a Cosmos developer. And it would be difficult for them to go out and build a message recipient in the Move VM that understands their application. And so the alternative we present is what we call interchain accounts and interchain queries, which allow a developer to basically do something in a target VM without writing any contracts or deploying any contracts to that network. So as an example, the interchain account API allows you to basically do a call as if you were a local contract on that other chain, without having to hook up Hyperlane and figure out how to deploy your contracts on all these other chains where you want to do these calls. Instead, you just hit the interchain accounts API, and the API basically creates a proxy account on your behalf that'll do the call locally in that VM. This is super useful for basically like atomic composability. Like you need to, if you want to be able to interact with some DeFi protocol or something on another chain, you need to have like a local smart contract that interacts with that. The alternative is basically like you have an EOA and then you're taking on kind of a bunch of like centralized trust assumptions. And so with this model, you can like leverage all of the Hyperlane security models available and basically expand your application to a new VM or a new chain without even writing contracts in that target VM, which I think is like lowers the barrier a lot to people interacting with these new chains. And then similarly for the queries APIs, you can actually go and read, you can do a view call against a contract on another chain without ever deploying contracts to that chain or without ever writing contracts that target that specific chain. So we're starting to build these developer abstractions and APIs that are consistent across all these environments, present like a nice simple API that like is similar to the local chain development experience of like, okay, I just want to do a view call, or okay, I just want to like call this contract. It's a familiar developer experience, and it's kind of like abstracting away all of the complexity that's underneath the hood of like, okay, this is actually a rollup that's settling to Celestia, and it interacts with like some light client to get like proofs. Like, the developer doesn't have to think about that at all. So yeah, that's mostly the overview I wanted to give. Like I said, I would have loved to do a demo, but the Wi-Fi is not really cooperating. But yeah, if there's questions, happy to take those now.
Do you develop all the smart contracts on all these different type of security parameters yourself?
So like I said, we've started to have basically developer shops who have come in and recognized the potential of Hyperlane serving a unique need for them, and basically enabling them to get to market with connections to all these existing liquidity hubs that they want to leverage. And so they've actually, for the Move VM implementation that I gave in as an example, was actually a third party who came to us and said, hey, look, we see what you're doing with modular security. We're actually willing to build the smart contracts ourselves for this VM, and we just want you to basically review that and merge that into your relayer so that we can start to operate it across all these different chains. And so we're hoping to continue to expand that set of contributors. Definitely, we have like a ton of open source bounties. We have a really large bounty program that is also another way that we're kind of scaling the development of this to to new environments. But yeah, the ones we built in-house were basically Ethereum and Fuel, which still hasn't launched, but we built like over a year ago, and Solana. And then we collaborated with a Korean team for the Cosmos implementation. It was probably like a 50-50 split. And then for the Move one, it was, I would say, mostly like 75 or maybe 80-20 split between the third party and us. And so I think it proves kind of this model of like, hey, there's this framework for people to tap into. They recognize this is a way easier path to getting to market than building a whole new interop protocol themselves that understands how to verify Move on all these other chains. Like you can get to market, maybe make a strong trust assumption, and then later, once you've bootstrapped, you can actually justify your DAO giving some grant to someone to go and invest in that like client research and that sort of thing. But yeah, it's a great question. I think like that's one of our goals as an organization to invite basically the open source community to collaborate with us on these new implementations. And for the most part, the goal, again, like the reason why we're doing this in the first place is we want to have all the like business logic of the protocol be agnostic to the underlying VM. And so like the actual on-chain contract footprint is not very large. And there's basically working with like a cloud services provider called Kurtosis that allows you to do these like one-click deployments. So you don't even have to think about the kind of like cloud orchestration of spinning these things up. There's like a nice UI for configuring your ISMs. And yeah, you can basically, without doing BD with us, without doing this like client research or whatever, you can basically get interoperability to your chain. And so something I was hoping to maybe demo today was just like spinning up a local chain and sending messages from like the Anvil chain on my machine and a bunch of production chains that were already sending messages between, because there's no requirement that like the applications on those chains are taking on my new chain's trust assumptions, right? There's like this modular security interface, and so each new addition to the network basically is just a new expression of security preferences, and it doesn't influence the existing set of participants in any way. So there's no like risk of like adding this chain to the network. And our hope is that this allows people to expand the protocol for us and actually start to participate and collaborate on growing this interoperability protocol to new VMs and to new chain ecosystems that maybe we aren't even super comfortable with building in, but that we can provide this framework for people to yeah, just like there's literally like an implementation guide that describes the kind of like minimum viable hyperlane for all these new chain stacks. And we've actually had a few teams, like even the Move VM implementation has actually been entirely done by a third party, just using this guide and collaborating with us on Discord. And yeah, you basically just, you support the ISMs that the relayer knows how to deliver for, and you now are connected to the entire like network effect of Hyperlane on all the chains we're already on. And I think that is like really compelling for Appchain developers, because you can leverage all these existing network effects rather than having to go out and kind of do a ton of BD with some like security provider or some interop protocol that needs to spin up guardians for your new chain, or they need to like enter into some like revenue share agreement because they're taking on additional like operational costs to like add your chain to the network, or adding your chain compromises the security of the existing network, and maybe they view that as like a risk, and so they you have to go off and prove yourself for 2 years before they'll even talk to you about like adding your chain to their network. So yeah, there's just basically like in some of the existing paradigms, there's a lot of friction in expanding the reach of your application to new chain ecosystems, and yeah, we're hoping that Hyperlane serves as the basis for allowing applications to continue to evolve across these different infrastructure layers as they emerge. Yeah.
Is it when I deploy with Hyperlane on the chain and I select a like low security assumption, is it like permissionlessly connected to all the other Hyperlane things?
Yeah, that's exactly right. So you
Okay.
can run your own relayer.
Yeah, with like a
And-
multi-sig or...
Exactly, and the relayer, so this is what, I didn't talk a lot about it, but basically, when I say separating the transport layer and the application layer, this is similar to how the IBC protocol works, but basically relayers are permissionless.
Yeah.
And so you can spin up a new relayer that connects your chain to these other chains. Outbound from all those chains, you can just reuse the validators or the light clients, if they're available,
Yeah.
that are already running there. And then outbound from your chain, you can configure your validator, and on those all those other chains, you're just using a multi-sig ISM that reflects your validator. And so you can exactly permissionlessly connect your chain to all these other deployments. There's no...
So how would you argue against the argument that your security is as weak as the lowest security assumption you made?
Yeah, so great question. So this topology is basically like a path-dependent security model rather than like a path-independent security model. And what that means is like there's not some global security assumption. It's like depending on the path you take, you might take on different security assumptions. And it is true that like in general in security, like if you're taking on 3 security assumptions, it means you're basically taking on the worst one. And that is true in this case, but the idea is that you can use this as a bootstrapping mechanism. So you can get to market, you can have your new app chain, start to build a developer ecosystem and a product ecosystem, and get some traction that can allow you to then justify the investment into improving those assumptions, rather than preventing your application from ever even existing or reaching the market because there's this cold start problem on you having any attention on your product or on your chain.
And so would this bridge you create be upgradable
So
when it comes to security?
great question, yeah. So each message recipient basically has configurability over the ISM that they're using to verify messages.
Okay.
And our relayer will basically introspect those ISMs, and it recognizes certain ISMs that it knows how to deliver the proof data to. If there's some proof model that isn't available, basically, in our existing relayer implementation, you can just go in and submit a PR and just add a new like verifier type, basically. And yes, we basically don't want to, like, we have recommendations around how people should have these things be configurable, but we don't want to say to someone whether or not it should be upgradable. That's ultimately like an application's choice. But this is like a framework that allows them to de-risk that in the future, basically, of migrating to the light client from their chain when it is available, or the data availability proof, and none of the application logic has to change because you're still sending the same information over the wire. All of the application like messaging coding is consistent. The semantics of the like general message passing API are consistent, and this is another problem you see a lot in IBC. I don't know if you've worked with it, but the semantics of the message passing like tend to change based on the liveness of the validators or something. And so we're trying to like separate the security from the semantics and just the developer experience. And we think that that actually like enables a faster pace of innovation. But yeah, I just wanted to highlight that we also have some applications available off the shelf that we've kind of built as like templates for you to just get the juices flowing of what's possible with this system. And one of those is, I mean, the most common, I think, like interop application is just a token bridge. You want to move some existing token representation to a new ecosystem so that you can establish some liquidity there. And we've basically implemented this as an application with a UI that you can just go in and fork. Oh boy. That's a PagerDuty alert. I'll get to that later. But yeah, the idea is you can basically go in and use this application template, and this is already built to understand all of the VMs that we've already implemented. So you have all of the wallet connections that you need across Solana and Cosmos and Ethereum. It's basically this like fully kind of